Hi students, this is Ms. Medina and I'm going to record the Unit 1 study guide so you can prepare for your midterm exam. All right, in Unit 1 we covered rational numbers, irrational numbers, and I do believe this is RN 3. Rational numbers is going to be anything that you can write as a ratio, right? A over B. And it's going to include your integers, which is like -3, -2, -1, 0, 1, 2, 3, and of course it goes on forever on both ends. It's also going to include anything that can be written as a fraction, like 3 over 5, even your mixed numbers, 1.5. The irrational numbers, it's also going to include your perfect square, square root of 36. Why? Because this one equals 6, which is an integer. I like the square root of 49 because that's equal to 7. Square root of 121 because that's equal to 11. Now your irrational numbers are going to be the numbers that never end. It has to meet both requirements, okay, which is never ends and never repeats. And is the key word here. All right, and we have our famous constants like pi. Pi never repeats, and then it never ends, and we're used to that, right? We approximate it as 3.14, but we know that it goes on forever. But then there's also your non-perfect squares. Like the square root of 11, okay? The square root of 7, square root of 43. Because those numbers are not perfect squares, they're going to be irrational numbers. 4 always rules for rational and irrational numbers. Well, this can be almost always, right? So if you have rational plus rational, plus or minus rational, you're going to get rational. If you have irrational plus irrational, okay, you're going to get irrational. Not necessarily. So, for example, if it's minus, now it cannot be 0. So the answer cannot be 0, right? Because 0 is going to be rational, right? But anything else, as long as your answer is not 0, the answer is going to be irrational. Let me fix this up right here. Then there is rational times rational. That's always going to give you rational. And then we have irrational times rational. That's going to give you irrational. And the only objection here is that R cannot be 0. Because if R is 0, then the answer is going to be rational, okay? Because anything multiplied by 0 is going to give you 0, and 0 is rational. But this rule applies as long as R is not 0, okay? If you multiply any rational with a non-zero rational number, you're going to get irrational. And there's the famous one, irrational times irrational. This is the one where you must do the math because your answer can be either one. It can be rational or it can be irrational. Here you must simplify to figure it out. All right. When simplifying radicals, pairs go out and single numbers stay, right? So pairs go out as 1 and single numbers just go single. I mean, they stay inside, right? Using a factor tree, simplify this. So for example, with this one, I would say 108 is even, so I'm going to go ahead and divide this by 2, right? So I'm going to start over here. So 108 divided by 2 is going to be 54. So 54 times 2 times x to the 5th. Let me see, 54 is not a perfect square, and I know it's even, so I'm going to divide that again by 2. So 54 divided by 2 is going to be 25, 26, 27. So it's going to be 27 times 2, right? That's just the 54, right? All the other ones I'm going to carry along, right? So it's going to be times 2 times 1, 2, 3, 4, 5 x's, right? That's the green portion. And then, 27 is not even, but it is divisible by 3, right? So that would be 9 times 3. That's this part right here, the 27. So you have to remember to bring the yellow 2, the green 2, and the 5 x's. And then just breaking up that 9 one more time. So once again, we're making a factor tree, right? So the 9 becomes 3 times 3. There's already the red 3, right? The 2 2's and the 5 x's. All right, remember I said pairs go out as 1. So here's a pair of 3's. Here's a pair of 2's. Here's a pair of x's. Here's another pair of x's. Okay. So this pairs of 3's is going to go out as a single 3. This pair of 2's is going to go out as a single 2. Notice that I'm putting my little multiplication symbols. This pair of x's is going to go out as a single x. And this other pair of x's is also going to come out as a single x. And what's left inside? Inside is going to be a 3 and an x. And there was nothing outside, right? So we would multiply it to whatever is outside. But there's nothing outside. Well, there's an understood 1. But here we go. 3 times 2 is 6. So this is 6x squared times 3x. And that's how you simplify using the factor tree. Rules for radicals, adding and subtracting, you need to simplify and have the same radical. For multiplying, you just multiply coefficient times coefficients and radicands times radicands. Then simplify. Okay. Unit conversions. What are the 3 base units of the metric system? It's going to be grams. It's going to be liters and meters. What helpful saying do we use for converting between the metric system? King Henry died by drinking chocolate milk, right? This is the base unit. So it can either be grams, liters, or meters, right? This is your decimeter, your centimeters, and your millimeters. This is deca, hecta, and kilo, right? And they go up by a factor of 10. So if you're going from right to left, right, the decimal moves to the right. Like, so for example, if you're going from kilo to millimeters, you would move the decimal 1, 2, 3, 4, 5, 6 times. And if you are going from in the left direction, then the decimal moves. All right, so let me see. 3 kilograms would be 1, 2, 3, 4, 5, 6. So it would be, here's your understood decimal, right? 1, 2, 3, 4, 5, 6 milligrams. Or if you have 20 centimeters, you have 20 centimeters and you want to go to base, right? That's 1, 2 to the left. So the understood decimal is there, so 1, 2, so it would be 0.2 meters. When converting between non-metric units, units must be located in across each other, numerator and denominator. In order to cancel them out. So then polynomials, adding polynomials, you have to have the same base and the same exponents. So this is a plus sign, so we can ignore, and there's nothing to distribute into the parentheses. So all we have to do is find like terms, 7a. A here doesn't, remember that's an understood one. Nobody else has an A, so this one is going to be by itself, right? Let's see, the other one that we have is negative 5a squared. This is a cubed, this one is a squared. So those are like terms. Negative 3 is just a constant, and so is positive 8. And I guess this one is by itself. All right, so which one has the highest exponent is going to be this one. This is by itself, we just bring it along. The next highest exponents is going to be those, so negative 5 plus 3. Remember, we talked about this. Negative 5 plus 3 is going to be negative 2a squared. And this one, plus 7a. And then lastly, the negative 3 plus 8. So negative 3 plus 8 is going to be a positive 5. And that's how you would add polynomials. Subtracting them, you have to distribute the negative sign. Remember, distributing the negative sign means you're multiplying by negative 1. So hopefully y'all feel a little bit more comfortable with this now. So you have a squared plus 6a minus 1. We need to subtract 5a squared, right? We need to subtract 5. And then we need to subtract 5a. So notice what I did is I placed it underneath each of them in a stacking mode, so it's a little bit easier to combine like terms, right? So these are like terms, those are like terms, and these are like terms. And so here we go. A squared minus 5a is negative 4a squared, my bad, right? Because this is an understood 1. 1 minus 5 is negative 4. This is positive 6, negative 5, so you're going to get positive 1a. And negative 1 and negative 5, they both have the same sign, so it's negative 6. All right, multiplying polynomials is when we use the distributive property, and remember, same base at the exponent when multiplying. Same base, add exponents. So 4 times 7 is going to give us 28. X times x squared is going to be x cubed. 4x times 5x is going to be 20x squared. And 4x times negative 3 is going to be negative 12x. There you go. Binomials. All right, so the way we did binomials in class was through the box method, right? So we said 6p negative 7, 4p negative 4, and hopefully, you're all more comfortable with this. All right, so over here, you're going to do 6p times 4p. Over here, you're going to do 6p times negative 4. Over here, you'll do negative 7 times 4p. And over here, you'll do negative 7 times negative 4. I guess you can wrap all of them in parentheses. It really doesn't matter. Okay, so this is what you're doing. And then you just, this is kind of what we do. So 6p times 4p is going to be 20p squared. 6p times negative 4 is going to be negative 24p. Negative 7 times 4p is going to be negative 28p. And negative 7 times negative 4 is going to be positive 28. There we go. And the only ones that are like terms are going to be this one and this one. So your final answer is going to be 20p squared, right? This one. They're both negatives, so we need to add them and keep the sign, right? Negative 28, negative 24, so negative 52. So negative 52p, and then lastly plus 28. I know it seems like a lot of work, but all right, x plus 6 squared. Once again, I hope you remember that this is x plus 6 times x plus 6, right? Building your grid. Being careful, this one's going to be x times x. This one's going to be x times 6. This will be 6 times x and 6 times 6. Okie dokie. So this is x squared. X times 6 is 6x. 6 times x is also 6x. And 6 times 6 is 36. Which ones are like terms is going to be those two. And your final answer will be x squared. 6 plus 6 is 12. So plus 12x plus 36. All right, and this is page 1.